In the summer of 1936, during the worst heat wave ever recorded in North America, an Amish settlement in Lancaster County, Pennsylvania kept every jar of butter, every crock of milk, and every side of cured meat at a steady 55 degrees, without a single block of ice. Their neighbors were losing food by the cartload. The Amish families on those farms lost almost nothing. What they were using was not magic, and it was not luck. It was a method older than the country itself, built from materials that cost less than a good meal, and it works so reliably that those same families are still using a version of it today. Now here is the part worth sitting with for a moment. This method did not begin in Lancaster County. It did not begin in America at all. It began in a desert city that has been continuously inhabited for over 7,000 years, and the physics behind it have never once stopped working. A city called Yazd, sitting in the middle of the Iranian desert, where summer temperatures regularly push past 104 degrees Fahrenheit. 7,000 years before a single air conditioning compressor ever turned over, the people of Yazd were keeping their homes, their food, and their water cool enough to live comfortably through conditions that would shut down a modern suburb in 3 days. They built tall towers called badgirs, some of them rising over 100 feet, designed to catch wind from any direction and force it downward through the building below. 700 of those towers still stand in Yazd today. The tallest in the Dawlatabad garden still works without a single replacement part. Nobody calls a technician, nobody pays a monthly bill. But the tower was only half the system, and this is the part that almost nobody mentions. At the base of those wind towers, the Persians placed wet charcoal and water-filled clay vessels directly in the path of the incoming air. The air was forced down through the tower, passed across those wet surfaces, and gave up its heat through evaporation before it ever reached the living space. Researchers from the University of New South Wales measured what that combination actually produced. Buildings in Yazd equipped with badgers maintained indoor temperatures 8 to 12 degrees Celsius cooler than the outside air during peak heat hours. That is 14 to 21 degrees Fahrenheit of cooling in a desert, with no energy source beyond wind and water. So why does evaporation cool the air so dramatically? Because every gram of water that evaporates absorbs 539 calories of thermal energy from the surrounding air. That heat does not move to another corner of the room. It disappears from the air entirely. Your body runs on the same principle every time you perspire. A breeze across damp skin feels cool precisely because the evaporation is pulling heat away from you. Activated charcoal does the same thing, except its internal surface area is almost beyond comprehension. 1 gram of activated charcoal contains between 500 and 1,500 square meters of porous surface folded inside a piece you can hold between 2 fingers. That is more surface area than the floor plan of a large house, packed into something the size of your thumbnail. Saturate those pores with water, place the wet charcoal in the path of moving air, and the evaporation happens continuously across all of that surface at once. In 2022, the Journal of Engineering and Applied Science published results from an experiment using activated charcoal as a cooling medium, starting temperature 95 degrees Fahrenheit. The air coming out of the other side, 75 degrees. A 20-degree drop with no motor, no refrigerant, no electricity of any kind. A bag of activated charcoal, the loose granular kind sold for aquarium filters at any pet supply store, costs between $5 and $8. A shallow tray costs nothing because you already have one. Water from the tap costs nothing. Here is how the Amish families in Holmes County, Ohio set it up, and how the same principle applies in any room you already own. Spread the charcoal roughly 2 inches deep across the tray. Pour water over it until every granule is saturated. Let it absorb for 5 minutes, then drain off any standing water. The charcoal should be soaked through, not sitting in a puddle. The entire process takes about 15 minutes, and most of that is waiting. Placement is where this either works or it does not. The tray goes on the floor directly beside the window or door where air enters the room. Every bit of air moving into that space should pass over the wet surface before it reaches you. The Persians understood this 3,000 years ago, which is why they placed their cooling materials at the base of the tower. at the exact point where air entered the building. The charcoal is not filling the room with cool air the way a machine would. It is a treatment station for the air that is already moving through. Position it in that path and the whole room benefits. Position it anywhere else, and you are cooling a 6-inch radius around the tray and nothing more. Maintenance takes 30 seconds each morning. Pour 1 cup of water over the charcoal to keep it saturated. Once a month, spread it in direct sunlight for a full day. The ultraviolet light resets it to full capacity. 1 bag lasts an entire summer. Replacing it the following year costs another $5. Now, here is the detail that the University of New South Wales researchers noted and that almost no one has ever published for a general audience. The Persians did not use wet charcoal alone. They placed unglazed clay vessels filled with water directly alongside the charcoal at the base of the tower. Terracotta is porous. Water seeps slowly through the walls and evaporates on the outer surface, cooling the pot, cooling the water inside it, and cooling the air immediately surrounding it. 2 evaporative systems working side by side in the same airflow path. What the researchers found was not simply that the 2 effects added together. The cooler, more humid air produced by the terracotta vessel actually improved the performance of the charcoal alongside it. The combined system outperformed either component alone by a margin the researchers described as greater than expected from the sum of the parts. A standard unglazed terracotta pot from any garden center costs $2 to $4. Fill it with water, plug the drainage hole loosely with a cloth so water seeps out slowly rather than draining all at once, and place it next to the charcoal tray in the same airflow path near the window. The pot sweats, the charcoal evaporates, and the 2 systems feed each other. Total cost under $10. Total electricity required $0. An Amish family near Sugar Creek in Holmes County was running this same principle without ever having read a Persian engineering document. They used damp clay bricks alongside their charcoal trays. Different material, same physics, same result. That is what genuine knowledge looks like when it survives through observation rather than through textbooks. Now, a word on what to expect honestly. In dry climates, West Texas, Arizona, New Mexico, the Great Plains, the temperature drop can reach 13 to 18 degrees Fahrenheit. In humid climates, the Great Lakes region, the Gulf Coast, the Southeast, a realistic drop is 4 to 7 degrees. The physics are the same everywhere, but humid air already carries more moisture and leaves less room for evaporation. 4 degrees Fahrenheit in a bedroom in July is the difference between a sleepless night and actual rest. It is the difference between running the Amish cooling method on its own and pairing it with a window you would have opened anyway. It costs nothing after the first purchase, not 1 penny more. But here is the broader question that the history of Yazd raises, and it deserves a direct answer. How did a cooling method proven across 3,000 years of desert habitation, documented by Napoleon's own expedition artist in 1798, because French military engineers could not believe something so effective required no fuel? How did that knowledge become so scarce that most people have never heard it? The global HVAC industry generates $130 billion every year. Residential air conditioning accounts for roughly 12% of all electricity consumed in homes worldwide. The architecture that became standard from the 1950s onward, fast to build, cheap to frame, indifferent to orientation or airflow, was designed around the assumption that mechanical cooling would handle what the building itself did not. The house became the problem, and the machine became the solution you paid for every month. The Amish families in Lancaster County and Holmes County never accepted that bargain. They kept working with the physics that were always available to anyone willing to pay attention. 7,000 years of proof. A $5 bag at the pet store, a terracotta pot from the garden center, 20 minutes of setup. That is the full cost of entry to a system that has outlasted every empire that ever tried to improve on it. Set it up tonight, measure the temperature before and after, and leave the result in the comments. Real numbers from real homes matter more than anything a laboratory publishes. And if you want to see what else these communities quietly worked out over generations, the next video covers a root cellar technique from Lancaster County that holds a steady 40 degrees year-round using nothing but a material found in any nearby creek bed. 4 generations of one family have used it, and it has never been written down anywhere online.